Hello children, in this lecture we will discuss next very important periodic property, that is ionization potential. It is in short represented as IP, and according to definition it is the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. Okay, so it is the energy required when an electron is taken out from any atom from its isolated gaseous state. Okay, so this electron will come out from the outermost shell of the atom. Okay, or you can say most loosely held electron will come out from the atom. Most loosely held electron. Okay children, so when an electron is taken out from any atom, then related atom will be converted in the form of positively charged ion. Okay, so we can represent the loss of electron in this way. Removed electron is written towards the right hand side with positive sign, and if we are going to write this electron in left hand side, then the sign should be minus. Okay, so in this way we can able to equalize the charges on both the side. Okay children, now we will discuss this ionization potential in detail, and for this we have to move page number 10, where heading is periodic trends in properties and ionization potential. So the term ionization potential or ionization energy. Ionization potential is also known as ionization energy. The amount of energy required to remove a loosely bound electron from the outermost shell of an isolated gaseous atom. Okay children, isolated means the atom which is present in a lone condition. Okay, means without any surrounding. So the atom should be in isolated state. Okay children, so if surrounding, or you can say that around the atom other atoms will also present, then the energy which will be required to remove an electron will not in its absolute value. Okay, so that is why the atom should be in isolated state and gaseous form. Okay, gaseous form. So you know that in gaseous state most of the elements are present in isolated form. Okay children, so this is an atom, nucleus and shell and shell and shell. So electrons are present in different shell. There are total 3 shells with electrons. So you know that nucleus of the atom is positively charged central part of the atom, whereas these shells or energy levels are circular path around the nucleus, in which a specific number of electrons are revolved. Okay, so you know that as far as the distance from the nucleus to the shell increases, the force of attraction of the nucleus to the electrons decreases. Okay, it means the electrons which are present here in this outermost shell will be most loosely held electrons. Okay, children, and when we are going to supply energy to take out an electron from this atom, so first the electrons which will come out will belongs to this outermost shell, that is third shell here. Okay, children, so at once only one electron can be taken out, only one electron. Okay, so you can say that each electron is related with a specific amount of energy, and that is why each electron will be require a specific amount of energy for its removal from the atom. So energy required to remove first electron is called IP, and we can represent equation in this way. This is a neutral atom, positive charge ion and electron. So first IP is less than second IP. Okay, so when first electron is taken out from the neutral atom, the energy required is known as first IP value, and when the second electron is taken out from the unicharged ion, then the energy required is known as second IP value. And it is always true that value of first IP will be less than the second IP. Okay, children, and according to different experiments and the results, we can say that from an atom maximum 3 electrons can be taken out. Okay, so the electron, when first electron is taken out, first IP value, second electron is taken out, second IP value, and third electron is taken out, third IP value. So third IP value will be highest value. Unit of ionization potential, electron volt. Okay, and this electron volt can be write in short as EV. Factors which affect the ionization potential, very important. First is atomic size. So as atomic size increases, ionization potential decreases. Okay, children, reason: atomic size increases, the nuclear attraction on the outer electrons decreases. Atomic size or atomic radius increases, then क्या होगा? Attraction of this nucleus to the electrons will decrease, and hence the outer electrons are loosely held. IP will also decreases. Okay, children. So for example, if this is an atom with 3 different shells, and this is any other atom with 2 shells, so distance in this atom for these outer electrons is comparatively less, means the force of attraction of the nucleus for these electrons will be more, and here it will be less. Okay, so first IP value for this atom will be less, and for this atom will be more. Okay, children, so if the size of the atom increase, ionization potential will decrease. The second, nuclear charge increases, ionization potential increases. Nuclear charge increases, the nuclear attraction on the outer electrons increases, hence the outer electrons are more firmly held, and ionization potential will also increases. Okay, children, so if 2 atoms with same number of shells with electrons, but let this atom with more nuclear charge and this atom with less nuclear charge. Okay, so the atom with more nuclear charge will has higher ionization potential value in comparison to this atom. Then third point, trends in ionization potential across period from left to right. So from left to right in period, ionization potential increases. Okay children, first point, atomic radii decreases when we move from left to right in period, and that is why ionization potential will also increase. Second point, nuclear charge increases, and due to this also ionization potential will increase from left to right in the period. Okay, so due to these two factors, atomic radius and nuclear charge, radius decreases and nuclear charge increases from left to right, and that is why ionization potential increases. The element helium has the highest ionization potential while cesium has the lowest. So underline these two elements. These elements can be asked to you. Lowest. Why? Because francium is a radioactive element. So francium is not included in regular elements. So cesium will be with least ionization potential value, and helium with highest ionization potential value. Metal lose electrons and generally have low ionization potential compared to non-metals. Then trends in ionization potential down a group. So down a group, from up to down, atomic radii increases, and that is why ionization potential decreases. Nuclear charge increases, ionization potential should increase, but the increase in atomic size dominates over increase in nuclear charge, and that is why overall ionization potential decreases when we move from up to down in a group. Okay, so two factors are working for ionization potential, and the effect of these two factors are opposite of each other. Atomic radii is increasing, nuclear charge is decreasing. So increase in atomic radii is a dominating factor, and that is why overall ionization potential decreases in the group. Okay children, thank you.